The next topic of discussion is gravitational potential difference. So to begin with, we'll look into ways to mathematically compare 12 and 3. So the first way is with symbols. So we have 12 being greater than 3. Next, we can divide. That is ratio. 4, is it not? So 12 is 4 times that of 3. So this is with ratio. 12 minus 3. Here we're looking at difference. So we can compare these two numbers with percentage also with quite a few ways. So the point here is we can compare these two numbers with difference. Okay, so we can subtract and compare them. Now, with this in mind, can you answer this question? What is the fundamental idea of gravitational potential difference? So the key word here is the word difference. So we just saw that difference is a way of comparison. So we are comparing over here. So what are we comparing? Again, the name makes it clear. Gravitational potential energy between two different points. That's what we are trying to compare. So to put it as a definition, gravitational potential difference is a way of comparing the difference in potential energy of two different positions. As simple as that. So now, how does this help? I mean, taking the difference, the definition and all that is quite simple. But how does this help? It helps in talking about motion. Again, all this concept is very simple. You might feel that, why is that we are discussing all this? But yes, all these are interconnected and as a whole, it looks complicated. But when you divide it into subparts, it looks simple. So if you're feeling all this is very simple, the topic is that simple. Okay. Now, it helps in talking about motion, but why should we talk about motion? That can be your next question. See, current is flow of charge, right? Current is flow of charges. So basically, we're talking about motion. So the idea of motion and linking it to gravitational potential difference is very important because the next thing that we are learning is electrical potential, energy, electrical potential difference, right? So there we'll get to link it with current. So that's why we need to understand this. So there are different cases of potential difference, it being positive, zero, if not negative. So my simple question to you guys is, when will we see motion? When will we see movement? Is it when it's positive, when the potential difference is zero, or when it's negative? Well, when it is positive, not when it's zero, not when it's negative 2. So we don't see movement in two cases, but we see movement only in the first case. So to make it clear, what is that we're exactly talking about? I have an example. Say I happen to leave a ball at point A. What happens to that? There are a set of questions. You guys answer this. So yes or no questions. Simple, straightforward yes or no questions. So the question is, if we place an object at A over here, will it move to B? Yes, it's very clear. Why? This is at higher potential. Okay, the potential energy over here is greater than potential energy at point B. Make sense? So it will move down. So what will be the potential difference? Will it be a positive value or negative value? So here the potential difference between A and B is positive. And so we see a movement. So answer is yes. Next question. If we place an object at B, will it move to A? Answer is no. Why? Clearly, potential difference between B and A is negative. That is, if we subtract potential energy at B minus potential energy at A, we'll get a negative answer. Now, one more, two more set of questions. I'm hoping that you guys are answering. That's why I'm waiting. So, what is that we're looking at? If you place an object at M over here, will it move to N? Clearly, no. Similarly, the next question too, no. Why is it so? The potential energy at M is equal to potential energy at N. The difference in the potential energy at M and N is 0. And so an object will not move. Does it make sense now? So potential difference helps us talk about with values, that is. I need not show you guys any diagram, nothing. I can just tell you guys a value. Example, the potential difference between M and P is positive. Will the object move? Yes, right? Because point M is at a higher altitude than point P. Something like that. Right? So here point M will be there and somewhere down the line will be point P. So this is the fundamental idea behind the potential difference. It's a very clear word, nothing much to this. So, but yeah, very useful idea. It will help us understand a very difficult topic for many, that is voltage. So please pause and make a running note.